Bismillahirrahmanirrahim. Today, inshallah, I'd like to do 3 examples of example questions about vertical motion equation. I found this nice set of examples here. The first one is this. Let's read together. Mrs. Wood, she's going somewhere. I don't know where she's going. I don't know Mrs. Wood. I just found this on the internet. So Mrs. Wood, she forgot her car keys, alright? She is in a hurry, and you can just imagine she's getting out there, and she forgot her car keys. She goes, calls up a friend to drop the keys. Okay, her friend is gonna drop the keys, alright? Out the window. After finding them, I presume, you know. Out the window from above the ground. If Mrs. Wood's hand is 3 feet above the ground when she catches it, how long does it take for her to receive the keys? Okay, so we got the situation here, right? So let's see if we can figure this out. So here's Mrs. Wood, alright? Alright. I don't know about you, but in my mind I was imagining the building to be kind of like over here. And let's say, okay, here's a buddy, okay? Let's give Mrs. Wood a little nice little flowery window over there. Okay, here it is. So, her friend, she's going to drop the keys from here, from a height that is from here to here, that's 75 feet, okay? Alright, and Mrs. Wood is going to catch it, see, and it's not 3 feet, but she's going to catch it 3 feet above the ground, okay? So what we do here is, first thing I would do is actually just write the vertical motion equation down, you know? So we know it's going to be a vertical motion equation question, so let's just write the equation and the function down. The vertical motion function, as you recall, is this, negative 16t squared plus vt plus s. Now, in this case, now her buddy, see, the question explicitly said the buddy's going to drop the keys. The buddy's not going to throw the keys. You know what I'm saying? It's very important. So initially, just going to go there and just let the keys go. That's important because that means that the initial velocity of the keys is 0. See, it's like an apple dropping from a tree. Same example. If an apple drops from a key, her friend is not dropping the key, is not throwing the keys down there, dropping the keys down. So the initial velocity for the keys is 0. So this term is going to be eliminated, right? The initial height of the keys is going to be 75, right? We know. And it's important because this is all in feet, and this equation is acceleration due to gravity in feet per second squared. So that's important. So this is in feet. And she's going to catch it over here. So the question specifically was asked, we have to make sure we asked how long does it take for her to receive the keys? Okay, so that's what we're going to try to answer here. So for Mrs. Wood here, the equation then becomes this, negative 16t squared. That term is gone because initial velocity is 0. And the initial height is 75. Now, the question is, how long does it take for the keys to arrive over here? Right? Okay. So, how do we figure that out, you wonder? Well, the answer is, how long does it take for the keys to go from here to over here? Okay. In other words, the height here is what? The height is 3 feet. Okay. So the height of the keys is initially 75, and as time goes down, the height of the keys is going to be smaller and smaller and smaller and smaller and smaller and smaller until it's 3 feet like that, right? So we try to find the time it takes for it to be 3 feet. So we know this height has to be 3 feet when she catches it. So that's the setup we have, okay? So the first thing we did here was to write the vertical motion equation as it applies to this particular scenario. And for this particular scenario, this middle term was eliminated because the initial velocity, because the keys were being dropped, is 0, and the initial height was 75. So given those parameters, the vertical motion equation simplified for us to this. Now that we have the vertical motion equation, we want to know how long will it take for the height to be 3 feet. And that's easy enough. So we say height is going to be 3. It's going to be negative 16t squared plus 75. And we just have to solve for t. Subtracting 75 from both sides, you get negative 16t squared is going to be negative 78. And then you divide both sides by negative 16, you get 78 over 16. I hope you followed this because, you know, I'm kind of doing a little bit mental math here for you, okay? Now to solve this for t, you take the square root of both sides, and it's going to be square root of 78 over 16. In this case, the negative square root is going to be meaningless because time is not going to be a negative number. So the answer is going to be square root of 78 over 16. So let's do that. So we take square root of 78 divided by 16, and that is 2.21 seconds. We give you 2.21 seconds. You better put our hand out in 2.21 seconds. So 2.21 seconds. So that's how long it's going to take for Mrs. Wood to get her keys and get on with her the rest of her fine day. So this was the first example, Mrs. Wood and her keys, and I thought it was an interesting example to start with. Okay, I'd like to do 2 other problems here. It's just I thought were also very good. Now, here's a frightened cat. So a frightened cat jumps straight into the air with the initial velocity of 14 feet per second. How long will it take for the cat to reach the ground again? Okay, this is also a nice one. So here's a frightened cat. We just try to draw a frightened cat. You know? So it's like, here's a frightened cat with the hair sticking over there. Right? Ah! So here's a frightened cat. Okay, I can't draw a frightened cat, so forget we're drawing a frightened cat. So this frightened cat jumps off from the ground, okay, like this. And it has an initial velocity. See, here's the initial velocity. I put V0 for initial velocity because I just like that and it looks cool. So initial velocity is 14 feet per second, okay? So that's pretty good. That's 14 feet. The cat's jumping 14 feet in 1 second. That's pretty fast. 14 feet per second is the initial velocity of the cat, okay? So the cat's going to jump. And then the question then becomes, how long will it take for the cat to reach the ground again? So how long will it take for the cat to go up and go down again? Okay, that's what we were asked to find out. Okay, well, this is a vertical motion equation question, so let's write the vertical motion equation. I'm almost tempted to write the C of t for the cat, C-A-T, it's kind of funny, so let's write it that way. The vertical motion equation for the cat will be C of t, negative 16t squared plus vt plus s, okay? And for her, she has an initial velocity, or the cat has initial velocity, and that's 14. We are given this, right? So we're given that the initial velocity for the cat is 14 feet per second, right? And, well, what's the initial height? Well, the initial height is 0, right? Because the cat's starting from 0. Okay, so that is 0. That helps us out. That's going to be 0. So for the cat's vertical motion equation, it then simplifies to the following: negative 16t squared plus 14. I'm going to get rid of the units for simplicity purposes, and 14t plus 0. Okay, so this is the vertical motion equation for the cool cat. No, not, well, temporarily startled cat. And now we're asked to find out how long it takes for it to go up and go down. So how do we go about figuring that out? If you want to think about that for a second, this would be a good time if you want to pause the video or something like that and think about it, and think about the cat. I do not recommend doing any experiments on the cat and trying to find this out because, you know, cats are cats. And don't. So anyways, so, all right, so the way I would do it, okay, so what the vertical motion equation gives you, if you like to think about this, is the height of the cat at any given time, right? So it gives you the height of the cat. Now, you don't know how high the cat is going to jump, okay? Now, we can find out, actually, but we can. I'll let you think about that one, how high the cat will go, okay? That's a question this test does not ask. But that's an interesting question for you to ponder. How high will the cat go? But anyways, this vertical motion equation question basically tells you how high the cat is going to be at any given time. What we want to know is how long will it take for the cat to go down. Well, what's the height of the cat when it reaches to the bottom? Well, it's going to be 0. Yeah, it starts out at 0 and ends at 0. Okay, so we want to know how long it will take for it to become 0 again. So we set this equation to equal to 0, like this. And then we solve for time, how long it takes for it to be 0. Okay, how do we solve this? This is a quadratic equation now. You're not going to complete square, none of that stuff. You're going to factor out a t over here, like this, okay? So, yeah, do that. And I get negative 16t, factoring out a t, plus 14 equals 0. Okay, from the zero product property, you get t equals 0. In this answer, you get two answers. And you get negative 16t plus 14 equals 0. Then negative 16t equals negative 14. T is going to equal to 14 over 16, or 7/8 seconds. Okay, if you really want to know what 7/8 of a second is, I can tell you that too. 7 divided by 8.875 seconds. That's going to be 0.875 seconds. That's how long the cat is going to be in the air. Okay, 0.78 of a second in the air. Now, notice that this equation gave us two answers. The cat's height is going to be 0. The cat's height is going to be 0 2 times. At time 0, and that makes sense. In the beginning, the height is 0. And at 0.875 seconds, the height is going to be 0. So the time is going to, it take for the cat to land back is going to be this much. Okay? So I thought that was an interesting question as well. Before I finish, I'd like to do another question. So let's read this. Okay. So a cherry falls from a tree. Finally, a cherry question. Okay. A cherry falls from a tree branch that is 9 feet above the ground. What is the height of the cherry after 0.2 seconds? Okay. I could do that, I think, inshallah. So let's check it out. So we're talking here about a cherry. So here's a tree branch. Okay, I'm going to draw out a little cherry. So the cherry is going to fall. Let's write the vertical motion equation for the cherry. So h of t is going to equal to negative 16t squared plus vt plus s. So now the cherry falling equation, what do we know about this? Well, we know the initial velocity is going to be 0 because it's falling. Initially it is 0, right? That helps us. And the initial height we were told was 9 feet. Okay, let me just double check this. It's 9 feet. Okay, so then this vertical motion equation simplifies for the cherry as negative 16t squared plus 9. Okay, so that's the vertical motion equation for the cherry. Now we were asked to find out how high will the cherry be after 0.2 seconds. That's easy enough. You just plug in. That's basically asking what is h of 0.2. That's negative 16 0.2 squared plus 9. Okay. Okay. And if you do this, let's just do this. Okay. So you get negative 16 times the quantity 0.2 squared. Okay, plus 9. Okay, that's 8.36. 8.36 feet. That's how high it's going to be. Right? After 0.2 seconds, it's going to be 8.36 feet. Okay? This question's got two parts. Okay, we got that. So it's going to be that. Okay, how many seconds does the cherry... After how many seconds did the cherry hit the ground? Okay, so how long does it take for the cherry to hit the ground? Okay, how do we do this one? This should be familiar enough. How do we do this? Well, when the cherry hits the ground, the height of the cherry is 0. Okay, so we make that 0. So the 0 is going to equal to negative 16t squared plus 9. We go back to that. And then we solve for t. That's easy as that. And how do we do that? Well, solving for t. Negative 16t squared is going to equal to negative 9. T squared is going to equal to 9 over 16. Okay, and so t is going to equal square root of that. It's going to be plus or minus square root of 9 over 16, which is 3/4. Again, negative answer is meaningless because we're talking about time. So t is 3/4 of a second, or 0.75 seconds. Okay. All right. So it's going to be pretty quick. Okay. 0.7 let me just write down the decimal, 0.75 seconds. That's how long it's going to take for the cherry to hit the ground. I thought those are a good beginning work or kind of workout type vertical motion questions. Inshallah, next time we'll do some more examples, perhaps a little bit more trickier. Until then, assalatu wassalamu ala rasulillah wa alameen. Assalamu alaikum.